Dear students, welcome to the course on Statistical Methods for Psychological Research Part 2. In this lesson, we are going to learn post-hoc comparisons in one-way ANOVA. What are you going to learn in this lesson? Let us look at the learning objectives. After completing this module, the student will understand the need for post-hoc comparisons. They will be able to test the specific differences between the means. They will be introduced to various methods of post-hoc comparison. They will apply the post-hoc methods learnt to the given case scenario. Let us start. We begin with the first part of the lesson, in which you will learn the introduction to post-hoc comparisons and to case test. We will recollect the previous concepts learned in the lesson, need for post-hoc comparisons, various methods of post-hoc comparisons, and to case HST test. In testing of hypothesis, rejecting the null hypothesis is known as statistical significance. It is a way of quantifying whether a difference has happened due to some factor of interest or some treatment or intervention or due to chance. When a result is significant, then it is considered to be true. What is meant by true? True indicates that the differences are observed in the sample as well as in the population. Significant ANOVA result refers to the non-equality of K population means. In the previous lesson, we have performed a F test for the case scenario called anxiety score. In that, we have shown there was a differences between the three interventions we studied, but it does not reveal which pair of means are significantly different. When t-test is applied to only the largest mean difference or all possible differences between the means, type 1 error will increase. For this reason, we are going to a post-hoc comparisons. It is otherwise called multiple comparison test, acronymed as MCT. It is otherwise called as posteriori test, pairwise comparisons, etc. Post-hoc tests are ranked based on their conservativeness, statistical power, and flexibility in computations, etc. In the previous lesson, we have introduced a case scenario for explaining the one-way ANOVA procedure. This problem is that distraction is a technique of diverting the patient's attention from unpleasant and painful dental procedures. A dentist wishes to compare the child's dental anxiety score using the child fear survey schedule, dental subscale, during the procedure between three different pain management techniques. The techniques were storytelling technique, musical audio, and audio-visual technique. So, let us consider this statement of problem for the future discussion. So, this was the ANOVA summary which was being produced when we performed one-way ANOVA. So, for this discussion of interest, we are going to take some input from this table. That is, we are going to take the degrees of freedom for treatment, degrees of freedom for error, and mean sum of squares for error. So, those were highlighted in yellow color. So, in this example, so we have rejected our H0, that we have concluded that there is a difference in the three pain management technique in the anxiety score. So, we wanted to further explore where the differences has occurred really, whether the differences are between the storytelling and musical audio group, or storytelling and audio visual group, or musical audio and audio visual group. So, these are the techniques of post-hoc comparison. The first one is Duncan's multiple range test, second one is Newman-Kuel's test, next to case HST test, Chef's test, and the last one is Bone-Ferrano test. So, using all this technique, one can perform a multiple comparison to see which are all the means are different from each other after the one-way ANOVA have proved to be statistically significant. So, let us begin with Tukey's HST test. HST stands for honestly significant difference. It is suitable when all pairwise comparisons are desired. It makes use of studentized range distribution for a given significance level. Studentized range distribution is nothing but a continuous distribution like a normal distribution, which we are going to use it for performing the Tukey's HST test, where we are going to take the critical value from this particular distribution. So, we will be discussing this in the future slide. It is based on the maximum difference in means, that is y bar maximum minus y bar minimum. We are discussing 3 groups in which we have 3 means y1 bar, y2 bar and y3 bar. So, whichever is a maximum and whichever is a minimum, we are going to take the difference of this. So, this studentized range distribution is based on this maximum difference in means. The statistic Q, which is the ratio of maximum difference in mean divided by the standard error, is actually following a studentized range distribution. So, based on this, we are going to discuss the test statistic for Tukey's test. So, the test statistic for Tukey's test is represented by Dij, which is nothing but capital Q multiplied by square root of SW square by 2 multiplied by ratio of size of the group 1 or the ith group plus 1 divided by size of the jth group, where I and jth group we are referring to any particular 2 groups. So, where SW square is nothing but the mean within sum of squares, Ni is nothing but the number of scores in the ith group, Nj is the number of scores in the jth group. Q is a value which is coming from the studentized range table, which we have already discussed. So, this table is an example of studentized range table, where it gives the value of Q for different error degrees of freedom and the number of groups we are comparing. So, in our example, we have 3 groups to be compared and we have our error degrees of freedom as 12, which is mentioned in the ANOVA table. So, this table is given for the particular level of significance alpha at 5%. So, let us look back our ANSITI data, where we have our research question. Remember that we have already rejected our overall one-way ANOVA test. Now, we are going to further explore which particular pair of means are different. So, let us consider the first difference, that is, we wanted to know whether the mean ANSITI score of the storytelling group differs from musical audio group. So, the research question can be put into the hypothetical format, put in the hypothesis format, that is mu1 is equal to mu2 versus h1 mu1 not equal to mu2. So, basically we are going to test whether the mean ANSITI score of storytelling group is equal to the mean of musical audio group, or we wanted to check whether the mean ANSITI score of storytelling group is not equal to the musical audio group. So, for testing this hypothesis, we are going to calculate the mean differences for this particular group. So, we are going to calculate the sample mean difference of these 2 groups, that is the 25.6 is the mean of first group, 44.4 is nothing but the mean of the second group. When we take the difference, we will end up with 18.8, and then we are going to find out the critical value, what is known as Dij, which I mentioned earlier. Now, it is converted into D12 because we are comparing the group 1 and 2. So, D12 is equal to Q, the same formula, but we are changing the size of the first group and size of the second group. Instead of Ni and Nj, Ni and Nj are the general representation for comparing any 2 groups. So, let us consider what are the ingredients of Dij in this calculation. So, the ingredients are mean sum of squares for error, that is 82.5, which we can take from the ANOVA table, and Q from the table just now I have shown, it is 3.77, size of the first group 5, size of the second group 5. Now, with all this input, we have found what is D12, that is 15.3. Now, how we are going to conclude is, since the mean difference that is represented by small d12 is more than the capital D12, which is the critical value of the Tukey's test, we are going to reject the null hypothesis. So, remember that in any testing of hypothesis, if your observed statistical value is more than the critical value, you will be rejecting your null hypothesis. In the same logic, we are going to conclude if the mean difference is more than the critical value for the Tukey's test, we are going to reject H0. So, we are going to conclude the mean ANSITI score of storytelling group differs from musical audio group. So, let us further move to the second pair, that is, we are going to compare this first group with the third group. So, the research question goes like this: whether the mean ANSITI score of storytelling group differs from the audio visual group. So, we actually wish to compare the mean of first group, that is mu1 is equal to mu3 against the alternative hypothesis mu1 not equal to mu3. For testing this hypothesis, again we calculate the mean difference of these two groups, that is y1 bar and y3 bar. We take a difference and the difference is found to be 16, and we are going to calculate what is Dij, that is D13. Now our comparison is between 1 and 3, so we have written capital D13. Again the size of first group and the size of the third group goes to the calculation. So let us look at what are the ingredients of D13, that is SW square remains the same and Q remains the same, only the size is going to vary. N1 is equal to 5 and N3 is equal to 5. So based on this, we have computed the D13, which is the critical value for Tukey's test, which is 15.3. So now we are going to compare the mean difference small D13, that is 16, and the capital D13, that is the critical value for Tukey's test, for making a conclusion, that is we are going to compare these two values. So since the mean difference is more than the critical value for Tukey's test, we are going to reject the null hypothesis. So we conclude that the mean answer score of storytelling group differs from the audiovisual group. And now we are moving to the third set of pair, that is the second group and the third group. So the research question is whether the mean answer score of musical audio group differs from the audio visual group. So this is the last comparison we are making. So we are going to compare in the null hypothesis mu2 is equal to mu3 against mu2 not equal to mu3. Again in the same way we are going to compute the mean difference between these two groups, that is the difference of y2 bar and y3 bar, which is 34.6, and we are going to calculate what is the critical value for the difference, that is capital D23. So the ingredients of the calculation again goes the same thing, only we have to change the sample size of each group 2 and 3, and after substituting all this ingredient in the model, we will get D23 is equal to 15.3. By comparing these two values, we are again rejecting the null hypothesis that the mean answer score of musical group differs from the audiovisual group. So we have analyzed the all possible comparisons between the three groups, let's say storytelling versus musical audio, storytelling versus audiovisual, and musical audio versus audiovisual. In all this, we have represented what is the mean difference, and we have also written the conclusion. So we will get an overall idea between which group we have actually got a significant result, which have proved to be contribute to the overall ANOVA. So from this table, this is not the actual table you will end up with while reporting the analysis of the Tukey's test. This is our basic understanding to know which groups differ significantly. So in continuation to this, we will also make a proper reporting table, that is reporting of multiple comparisons. So you have to write what are all the possible comparisons you have made, like 1 versus 2, 1 versus 3 and 2 versus 3, and you have also need to mention what is the mean of each group along with the standard deviation, so that we are actually comparing the two groups with so and so mean and with so and so standard deviation. So the comparison of these two means have end up the result as p is equal to 0.017, which is the p value which you can't calculate by hand, that software packages will give, like SPSS can give. So while comparing these two values, we are getting this p value. So from the p value you can able to interpret whether they are significantly different or not, but in the previous slide we have interpreted based on the critical value which is obtained from the studentized range table. So here whenever you are having the packages, you can use and you can get the p value. Most article will give a p value rather than the critical value. So while comparing storytelling group and musical audio group, you had a p value of 0.017. So recall the conclusion based on p value. If your p value is less than your level of significance, suppose your level of significance you have fixed it as 5%, so it is less than that, so you are going to reject the null hypothesis and you are going to say there is a difference between the mean answer score of storytelling group and the musical audio group. Similarly, you are going to reject the other two pairs because the p-values are again less than 0.05. In addition to the reporting of result in a table, you should also return in the form of text whatever you have concluded in terms of Tukey's test. So, the result of Tukey's HSD multiple comparison test performed for anxiety scores among the 3 pain management techniques are presented in table 3. It was found that there was a significant difference in the mean anxiety score between storytelling and musical audio and audio visual, and finally storytelling and audio visual. So, like this you have to report what is the understanding of the comparisons you have made in the Tukey's test in a proper way, so that your results will be concluded. So, finally I have made all mean anxiety scores are significantly different. So, actually this contributed to the significance of the overall ANOVA test. In this particular video, I have narrated how to explore further when you end up with significant results in one-way ANOVA, what are post-hoc comparison tests, various methods of post-hoc comparison. We have also discussed Tukey's test along with the application. I hope you understood all the concepts discussed in this video. We will continue in the next video. Thank you.